you have a circle inside a square. The diameter of the circle is d. You pick a point inside the square. What is the probability that the point lies inside the shaded region? Remember geometric probability?
Yeah.
It's one of those problems.
Okay, I'm thinking.
Okay.
Well, would you find the area of the circle and the area of the square and then put them, divide each other by them?
You find the area of the circle, area of the square, divide each other. Now what does that give you?
The probability.
Of?
The point lying on, or inside the square and not in the circle.
Is it inside the square and not the circle?
Yeah.
But you're dividing the area of the...
Oh, okay. If I want to find that white area that you have, I would divide the area of the square by the area of the circle.
Area of the square divided by the area of the circle. Now tell me, do you think the area of the square is larger than the area of the circle, or is it smaller?
Larger.
Larger. So when you say you want to divide the area of the square, SA, let's say A is for area, S is for square, and then CA. C is for circle, A is for area. Now, do you expect this fraction to be larger than 1 or smaller than 1?
Larger than 1.
Now, do you expect the probability of something happening to be larger than 1?
Oh, no, I don't.
It can never happen. Probability of no matter what is going to lie between 0 and 1, both inclusive. When something is impossible, we say it has got a 0 probability. When something is sure to happen, we say the probability is 1. Everything else is between 0 and 1. The more likely it is, the more it is closer to 1.
I see.
So this one is an absurd answer. You have to think harder.
Oh, did you want me to give you the probability?
Sorry, once again?
Did you want me to give you the probability?
Oh, yes. I just thought that you're thinking.
Oh, no. Maybe the circle area divided by the square area then.
Okay. So now you think it's going to be the area of the circle divided by the area of the square. Fine.
I do.
Obviously, that's going to give us a number that's less than 1.
Yeah.
Now, does this give you the... Huh?
Wait, yeah.
You're trying to say something?
I changed my mind.
You changed your mind, okay. Now, does this give you the probability of picking the point in the shaded region that lies outside the circle?
Yeah.
Okay, just think a little bit harder. I want you to push yourself a little more. Let's say there was no shaded region at all. If the circle is really small, this fraction is really small? Agreed?
Agreed.
If the circle is like something like this, a small circle inside the square.
So the probability should be pretty big that it would lie outside.
Exactly. But your formula doesn't support that. If I were to apply this formula, then the probability would be much, much small. Smaller the circle, smaller the probability.
Yeah.
So what's going on? On the other hand, if you pick a large circle, you expect this fraction to be close to 1, maybe 0.8 or something. I'm just guessing.
Yeah.
So this formula actually gives you something else. Tell me, what does this formula give you? Something related.
The probability that it would be on the outside of it. The probability that it would lie inside the circle.
Inside the circle, that's right. This gives us the probability.
Oh, and then you take that and you minus it from 1 to find the probability of it lying outside.
Spot on. The whole thing has to be 1. So the probability of the point lying inside the circle plus the probability of the point lying outside the circle has to add up to 1 because the point is either inside or outside. So the 2 add up to 1. This gives you the probability of finding the point inside the circle. You subtract it from 1, you get your answer.
Okay.
Okay. Now it's time for you to show me that you can work with the fractions. There will be some fractions involved.
Okay. He didn't give me the coordinates of a point or anything. Oh, it would be CA over SA minus 1.
CA over SA minus 1 is...
Or 1 minus CA over SA.
Right. That will be 1 minus CA over SA. But CA and SA, I want you to find in terms of the diameter D that's given. So I want an answer in terms of D.
So it would be pi 1/2 D squared.
Wait, are you talking about CA over SA or are you talking about the whole answer?
The C over SA.
Okay, can we just do CA over SA? To do that, let's break this down. Let's do CA first, the area of the circle.
Oh yeah, that's what I was giving you.
Okay.
It's 1/2. No, pi 1/2 D squared.
You mean like this?
Yeah.
Or you mean this?
I mean that.
Sure you do, because it's the square of the radius and the radius is half the diameter, so the half is also part of the square.
Got it.
Okay, so how do we simplify this?
1/2 pi times 1/2 D squared.
1/2 pi times 1/2 D squared. Okay, can you multiply the fractions out and give me one single fraction?
1/4
Correct?
pi D squared.
Right. Let's keep it at that. Maybe you could have written this as, it's the same thing. I mean, I don't care. Pi D square over 4. The same, right? Timesing with 1/4 dividing with 4 is the same. Let's talk about SA now.
Okay. So it would just be D times D.
It will be D times D. So that will be
D squared. So it's just 1/4 pi.
See the fun. The answer is independent of D. So the moral of the story is, no matter how big the circle of the square is, for every square and circle of this nature, such that the circle is inside the square and it just touches the square, the probability, it's always going to be pi over 4.
There's 1 minus 1/4 pi.
Correct. So the probability of finding the point in the shaded region is going to be 1 minus pi over 4. If I were in your place, I would do a quick check on pi over 4 to make sure this is smaller than 1. If not, I must have made a mistake somewhere. Because a probability can never be larger than 1, and not only that, you do 1 minus pi over 4. So if pi over 4 is greater than
3.14,
the
whole number is 3, and 3 divided by 4 obviously is going to be less than 1.
Perfect.
Because unless it's 4, it will be 1.
Okay, yes, I like that. So the answer is 1 minus pi over 4. Now it really depends. If it's a gridding question on your SAT, you would just use your calculator to find this answer. Sometimes people are so foolish, they don't look at the options. The options given are like A, B, C, D, and E. They give you pi over 4. They give you all sort of stuff like that. There's 1 plus pi over 4. And somewhere down the line, you have 1 minus pi over 4. And people, even without looking at these options, they start calculating. But the calculator will not help if you get options like this.
Right.
In terms of pi. Just one more thing. Sometimes in problems like this, you don't even see an option that is 1 minus pi over 4. You don't see this in any of them. Instead, what you see is something like 4 minus pi over 4. Now you have to understand, I'm just making things more trickier for you, just to give you more exposure. Now, this 1 minus pi over 4 is nothing but 4 minus pi over 4. If you combine them, so change the 1 to 4 over 4 minus pi over 4 so that you have like denominators, you can subtract. This becomes 4 minus pi on the top, 4 on the bottom. So it's the same thing. It might look different, as I said, but it's the same thing. So you just have to do that one extra step.
Okay, I see. So say it was the answer was like 1 minus pi divided by 3. It could also be 3 minus pi in parentheses divided by 4, or divided by 3.
Divided by 3, yes.
Okay.
So you have to identify that the two are the same. You might have solved the problem in this way and come up with this answer, and you don't find that. Oh, what? Have they given the wrong options? Now, they never give you the wrong options. And in this case, as it turns out, even you have done nothing wrong.
Yeah.
Okay.